Thank you guys for joining us today. My name is Wilson Withiam, research analyst here at Masari. And I am really, really excited for this panel today. We have some great, some of the top developers, researchers that really made ETH 2.0 happen and yesterday's launch happen. So I kind of want to go around, and if everyone wants to give a brief introduction as to kind of what they're doing, what they've really been focusing on, and then a nice gut check of how yesterday's launch went down. How are you feeling now? Now that we finally reached this first stage of ETH2. So Justin, I'll start with you.
Yeah, so I'm Justin from the Ethereum Foundation. I've been doing research on Ethereum 2.0, and also helping with the spec writing. It's been 3 years, so I actually joined the Ethereum Foundation on December 1st, 3 years ago. And from what I can tell, the launch of the Beacon chain has gone extremely well. Hats off to all the implementers who've done an amazing job there.
Excellent. Preston, I'll throw it over to you.
Hey, Preston Van Loon, co-founder of Prismatic Labs. I've been working with Ethereum for almost 3 years now, around the same timelines Justin said, and it's just been a really crazy adventure, and it's so cool to see that all of this work we've been doing. We're moonlighting for a year and then jumping in full time for the last 2 years. So to see all that work and effort and collaboration come together into one event was really exciting to see. So yesterday was a really cool day for us. I don't think it could have gone any better. We met all the things we wanted to see. Change started right away. We didn't miss the first block. Everything went well. So very happy with yesterday's result.
Awesome. Viktor.
So I'm actually over at Bison Trails, not one of the researchers, but I've been on the receiving end as a participant in a lot of this research, a lot of the client work, which we're extremely thankful for. And I will give a shout out to also Gary Tan's guide. I'm also using it and greatly enjoy it. I think the launch yesterday was incredible, just really breathtaking. And also in many ways, I found it, in the best sense of the word, anticlimactic. Nothing went wrong. Everything was smooth, and that's the way that it should be. And as boring as we could make it, the better that it is. So it was fantastic from my experience.
Yeah, it's one of the boring is good. So yeah, that's a great. Hsiao-Wei, glad to have you back on. So the question was just brief introduction and gut check. How you feeling after yesterday's launch?
Oh yeah, so I'm Hsiao-Wei. Hello everyone. I'm a researcher at Ethereum Foundation, and it was just so unbelievable that after the years of work and it finally happened. Yeah, so it was so exciting to me. Thank you.
No, thank you. All the hard work really kind of came together yesterday, and it was really exciting to see. So now that we are officially in phase 0, I kind of want to our viewers understand, what does this like really mean? Like how can developers, service providers, ETH holders, what can they do to interact with the network? And what is the Beacon chain doing, and what is it really validating at this stage? So Justin, I'll start with you, and then I'll head over to Preston.
Yeah, so in terms of what ETH holders can do, they can deposit their ETH and they can contribute towards the security of the Beacon chain, and they can get some rewards. And some people argue, and I would agree with them, that this gives Ether more money-like properties, because it's interest-bearing. You can think of it a little bit like an internet bond. In terms of other stakeholders involved, there's exchanges who are large ETH holders who are starting to get involved. We've seen announcements from Kraken, Bitstamp, and Coinbase. And in terms of what the Beacon chain is coming to consensus on is basically all the infrastructure, all the groundwork So that includes, technicalities like randomness, but also, keeping track of ETH1 deposits and keeping track of the registry of so-called validators that are the consensus participants, and keeping track of all the rewards and penalties and the slashing and all that stuff. So it's a lot of groundwork that's, to support the future phases around scalability and doing some VM upgrades as well.
Awesome. Yeah, go ahead, Preston.
Yeah, and I don't have too much to add there. I mean, it's all about laying the foundation for future phases, and you can be a participant. And for many, this is a new renewed opportunity, because if you were around early, you might have been able to mine a block on your own with your own hardware and own machine. And now it's just not possible. You need a whole server farm or whatever. But now you're able to do that kind of participation again with ETH2. So it's a new renewing of that excitement.
Got it. And so as a prospective staker, I want to get involved. What are some of the things I should consider before staking my ETH on the Beacon chain, and what are some actions you can take to get involved? And Viktor, I'll start with you.
Yeah. So there's a couple of primary paths that everybody has to make their own decision. I think before we kind of get into it, I want to give a shout out to the ETH staker community and all the incredible resources they and other folks have put together. The really amazing thing about ETH is that if you want to participate as an individual, you can, right? You need to make certain investments towards it, right? And you need to accept that responsibility. You need to be ready to maintain that commitment for potentially several years until that ETH becomes withdrawable. But those options are definitely available to you, and the resources to do that are thorough and extensive and really, really well made. So it's always a possibility. The other possibilities that folks can do are, of course, participating via the different exchanges, whether it's the Coinbases or other folks that are enabling this on behalf of their customers. And we do think that is ultimately going to be very important for giving more and more folks opportunity to to participate this in ETH2 in the way that is most compatible with their life situation and the responsibility they're able to take on. And the last one that I'll mention is of course you do have some infrastructure providers such as Bison Trails and other folks in the industry as well that tend to that want to make this easier, that want to make this more accessible. A lot of us are doing it in non-custodial ways, and we're all about focusing on how can we enable as many people to participate in ETH2 and of course in other networks as well as easily as possible. And so by democratizing that access, we're hoping to increase our participation and really get as many people bought into the vision and contributing security as we can.
Yeah, I want to extend this over to Preston. So what are some things that people should consider before getting involved?
Yeah, I mean, was that for Preston? Sorry.
Oh yeah, I want to extend that to Preston.
Sure. Yeah, I think the biggest thing is to understand the risks and what you're getting into. It's not a simple passive income. It's not like a savings account where you can set it and forget it. You're actually doing work. You're performing a service for the network, providing the security for the network. So you need to understand, what are the things you need to have a secure setup, and to what does it mean to actually to do that. Do a little bit of research, or maybe a lot of research, whatever you need to get to that comfort level. But definitely make sure you understand how the system works and what you're going to be doing before jumping into it, at least, especially because 32 ETH is not a small amount. It's a substantial amount to most people.
Exactly. Yeah, there's definitely a lot to the design in here, and so I kind of wanted to dig into that a little bit, because there's definitely the aspect of staking wars, but on the design side, really trying to create it so it could withstand an adversarial environment. So what I kind of want to talk about, and then extend this to Hsiao-Wei and Justin, is kind of what are the difference between penalties and slashings, and how do they get involved, and what conditions are there for a validator that could get penalized or slashed?
So penalties like if you are honest validators, but somehow you didn't perform well, and you will get some minor penalties because you lost some chance to make your attestation, your votes, or because you're offline for a while. So it's a minor penalties for not participating. But if you make some conflicting attestations or bugs, then that would be considered as type of attack to the network. So you will get punished seriously, and that is called slashing in our definition. That's basically the definition, in my opinion. Justin.
Mm-hmm.
Yeah, I would agree. I mean, slashing is a type of penalty. It's a larger type of penalty. It's like a one-off thing as opposed to a possibly prolonged thing during a period where your node is offline. I mean, one of the things I want to do is kind of try to reassure people around the slashing. So, it shouldn't happen, as Hsiao-Wei said, if you're running like an honest node. But there are some like mistakes that you could make. For example, if you're running two nodes at the same time, that's actually a bad thing. You want to try and optimize for safety as opposed to optimizing for liveness. And the other thing I'll mention around slashing is that even if you do get slashed because you do one of these human errors, user errors, the protocol is very lenient for these kind of isolated one-off mistakes. Really, where we're penalizing heavily is when there's mass slashing. So there's lots of correlated bad behavior. And the reason why we penalize that heavily is because from the point of view of the protocol, that looks like an attack or an attempted attack. And so that's where we defend ourselves.
Yeah, and if I can actually add really quick there, it's interesting, and Justin and other folks have pointed this out on Twitter, like the first slashings actually already happened on ETH2. Happened about 5-6 hours ago where, and I'm going to do a little write-up on it in our next ETH2 update, but this is like a little bit of a sneak peek, but we took a look at what's happening there, and it is an enthusiast. It is a whale that's been around for about 4 years now, or at least that's when his ETH started accumulating. He spun up 4 validators that are participating, which is a very small portion of his overall ETH, and has had a setup where he again over optimized for liveness and ended up getting penalized for it. So this does have real risks, and one of the major consequences is not just the punishment that you face, but also his validator is now no longer participating, and it's not able to rejoin the active set for an unforeseen amount of time at this point. So it's going to be foregoing a lot of rewards, not just worrying about how much money it lost currently.
Yeah, I think that's an important point, and exactly what Justin was bringing up too. That this is it will happen, but it's relatively a rare occasion, and it's more for the benefit of the overall network. And I kind of want to backtrack here a little bit and kind of talk about some of the differences in proof of stake versus proof of work, and kind of how the two differ, and what are some of the concerns and trade-offs between the two, because there's still a little some, but I really kind of nail it down, especially in terms of security and finality. So Hsiao-Wei, if you'd like to kick us off.
Yeah, sure. So it actually was discussed in one of Vitalik's recent post about why we do POS. So that's a very interesting and important question. So for the security consideration, I think, so if we compare to proof of work, that since the proof of work, the mining power, the hash power can be rent easily. You can buy a period of hash power at some website and at any time. But if you want to get some validator power in the proof of stake world in ETH2, then you have to actually to buy the validators who are already online. So it's more easy for the validators to in proof of stake world to recover from such like the 51% attack, because the proof of work attackers can rent the money power for surely, but it can't be reproduced easily in the proof of stake world. That's one of the security considerations.
Absolutely, yeah. As like a last resort kind of defense mechanism. Completely get that. So Justin, on the other side, how do they differ in terms of transaction finality? Because there's definitely a huge difference there.
Yeah, so for proof of work, we have what we call probabilistic finality. So we make some assumptions around, the miners. For example, we assume 50% are honest, and then with these assumptions, we can do statistics and say that if we have 6 confirmations or whatever, then it will be probabilistically confirmed. In Ethereum and in proof of stake in general, I guess we have this thing which we call economic finality. And so the idea here is that you can also make assumptions around the validator set. And here the idea is that for example, if 2/3 of the validators are honest, and you have them vote in a certain way, then this one block will be finalized. And the reason why we say it's economic finality is that if for some reason this assumption is not true, that there is some sort of 2 blocks that are conflicting, and both finalized, then at least 1/3 of the validators will get slashed. So we have kind of some economic guarantees. It's not perfect finality. Nothing is perfectly finalized. At the very least, you always have the social layer, on top of the consensus layer that can do these social forks. But it's one of the best ways of getting finality at the layer 1. In particular, in terms of user experience, it kind of reduces the time to latency. 6 blocks is a long time, but we can get it down to a few minutes in the context of Ethereum.
Excellent. Yeah, I think that's a perfect breakdown of some of the clear differences between the 2 consensus mechanisms and why there was a need to push for a switch going forward. So Preston, I want to jump into one of Ethereum's. I'd say one of the key things that they kind of focused on in general, both on the existing chain and on Ethereum 2.0, was the idea of client diversity. So taking a multi-client approach going forward, and having multiple viable clients on the network at launch. And so why is that so important to Ethereum, especially for this Beacon Chain launch?
So client diversity has always been a part of Ethereum since the beginning. And the main idea here is that if there's a fundamental flaw with any one of the clients, we have an option to choose another client and continue forward with the state of the network. So for example, in E2, we have 4 primary clients right now. We have Lighthouse, Nimbus, Teku, and Prism. And let's say that Prism can handle blocks over 1 million, and we know this is going to happen. We'll just say, all right, everyone who's using Prism, go to Teku or something else while we fix this bug, and everyone in the network benefits from this strategy because the network continues. The participants don't lose any money. They're validating. The key is that we have this redundancy option in client implementations, whereas something that has a single implementation just has to hope that they're able to fix the bug quick enough before it's exploited, and then ask everyone to update in the whole network, which is a very difficult task to do.
Is it relatively easy to switch from one client to the next, or are there some other standards and process to make that better?
Yeah. So one of the things we focused on and found in the testnet through sort of a global outage caused by Prism, in fact, is that we need this interchange format. We need an easy way to say, take all the data that I've been using with Lighthouse or Prism and let me import it into Teku or Nimbus. That's been a key thing that we've been working on.
Awesome.
Yeah, and this, if I can chime in, like this is something that, as an infrastructure provider that's running, Prism first and adding support for Lighthouse as well. And, we're extremely attentive, as is the rest of the community, around how do we enable every part of the stack to be able to be redundant or to be able to move things around really, really easily. And so on the client side specifically, all the clients essentially had to collaborate to a degree in order to make that portability really easy, so you can move the validators between the different clients. And also on our side, if that wasn't available, then all the different infrastructure providers would have to set up all their own systems and figure out their own processes by which you can move validators over without risking slashing or other types of penalties or having an extended period of downtime. So we're very thankful that the teams have prioritized this as a feature and recognize the importance of it to the stability of the network and to the infrastructure providers and participants, of course.
Oh, that's excellent to hear. Yeah, because that definitely there's also the built-in mechanism behind it of the fact that you actually want to run various clients instead of piling all in on one, because of the idea that if you're not reaching finality at a 66% rate, then you could be subject to some penalties as part of the inactivity leak that maybe we can dive into in a little bit later. But I definitely wanted to jump into what are some of the later phases, because phase 0 is awesome, but I mean there's a bunch coming up down the road, and starting with the next one, phase 1, going to introduce Ethereum solution for scalability, which is sharding. And so I kind of wanted to talk about what does sharding provide that some of the other scalability solutions may not, and are there any concerns or trade-offs that had to be made by going down the path with sharding? So Justin, I'll start with you.
Yeah, so it's actually possible that we'll have, likely that we'll have a fork before phase 1. I like to call it phase 0.5 because it's between 0 and 1. And it will provide support for light clients and do all sorts of other small things. And light clients is, so basically we're going to make ETH2 light client friendly, which means that other blockchains, including ETH1, will be able to have light client support, which means that they'll be able to read the state of ETH1, and that will basically allow, it's the basic infrastructure for building bridges, in particular bridges that allow you to send ETH bidirectionally. So kind of a small but important phase 0.5 fork. For phase 1, as you said, sharding, the idea here is specifically to come to consensus on data. So there's no execution, it's pure data. And data, having lots of data is interesting, for example, in the context of rollups. So rollups are what I call kind of execution minimized decentralized applications, meaning that they use a tiny little bit of execution. For example, you have to verify a snark every once in a while, or you have to verify a proof every once in a while. And most of the heavy lifting is just shoving data in the blockchain. And so this is where the scalable data will be useful. In terms of, I think you were asking downsides of sharding or the trade.
Any trade-offs involved?
Yeah, I think one trade-off is complexity. So you could take the brute force approach and just assume that your validators are have a whatever it is, a 1 gigabit per second internet connection, and just have one big shard, and then you assume your validators are very beefy, but then that comes at the cost of decentralization. So we've taken the approach to be maximally decentralized. So basically, you can think of conceptually as each shard from a resource perspective to be the equivalent of ETH1 today and no bigger. So, specifically with what we have in mind is, entry-level laptop or Raspberry Pi, or a home internet connection. That's the kind of hardware you should have. And I guess the trade-off of this is around complexity. So it took a long time, as was mentioned many times, to get Ethereum out of the door, and part of it is because it's a hard problem to solve this. The dilemma around getting all three of scalability, decentralization, and security. The good news is that in the data-only scaling, there aren't that many trade-offs. One area which will be interesting to see how it develops is once we have kind of more native execution on the shards, because one of the consequences is that communication across shards have to be asynchronous, and that I think that's fine. The Web 2 is built on asynchrony, right? If you think of loading a web page, you have JavaScript doing all these calls and loading everything asynchronously, and we still managed to build Web 2. So I'm confident we can also build Web 3 on an asynchronous platform. It's just a new programmer mindset, I guess, for these dApp developers.
There's definitely a lot to unpack there, but I definitely want to touch on one thing, is the phase 0.5 that you mentioned. So there is an opportunity that maybe there could be some cross-chain transactions between ETH1 and the Beacon chain before some of the later phases.
So I guess we like laying foundations. So phase 0 is laying foundations, and phase 0.5 is laying even more foundations. I think it would be too early to have this two-way bridge. One of the things that we have in the back of our mind is that we want to make sure the Beacon chain is ultra secure, on the same order of magnitude of security as ETH1 today. Because if we build a bridge and one is lower security than the other, then basically it's is the weakest link is what you get. So we want to make sure that they're roughly the same amount of security before connecting the two. Right now we have the privilege, the luxury of being able to experiment and move forward in a kind of isolated world, which is nice. We will definitely have this two-way bridge when we merge ETH1 and ETH2, and it is possible we'll have a bridge before that. One of the things I do want to point out is a point that Viktor made, I think, where if you want to become a validator, you need to consider the consequences of locking your Ether. And I think that's an overblown point. And the reason is that you can 100% trustlessly sell your Ether, even if you're a validator. And not many people realize that, but what you can do basically is you can stake your Ether, and then you can short, if you want to sell at some point, let's say in 6 months' time, you can short your Ether on some decentralized shorting platform. And that's going to cost you something, let's say 10% a year, but you're going to recoup your 10% anyway from the staking reward. So all in all is the equivalent as if you had sold your Ether while you were staking. And this can be done 100% trustlessly without exchanges doing these, exotic synthetic, assets.
That's an interesting way to think about it. Something I hadn't considered just because of all these derivatives opportunities that are popping up. I know the next panel is definitely going to get into that. I'll push forward, but if anyone has a question on that, drop it in the ask a question box. I'll try and spend the last 10 minutes here going through those. So I want to get in the transition from phase 0 to phase 1. What is that going to look like from a client perspective and a validator provider perspective? So I'll start with Preston on that. Is it going to add any complexity? Is it going to make it a little bit more work for the validator on the client side?
Yeah, that's right. So adding in phase one, which is to add the shards, the data layer to the beacon chain. So now the beacon chain is coming to consensus on a lot more data. So if you were running on a cheaper hardware, like I'm actually running on a cheap Raspberry Pi for mainnet. Even though people say you shouldn't do it, I wanted to try it. And it's working well, actually. So, but I know that having that Raspberry Pi, it's not going to work in phase one. It's just not going to be able to, I don't think it's going to be able to keep up with the amount of data we want to come to consensus on. So that's really going to be from like an operator perspective is you need to understand your resource requirements are going to go up. From an implementation aspect, there are quite a few changes coming in phase one on the back end. That we'll have to work through. It's not nearly as big as phase zero, thankfully, so it should not take nearly as long, but it is still a substantial piece of effort.
I mean, I kind of want to push back a little bit on Preston because, as you mentioned, phase one is all about coming to consensus of data. And so really the bottleneck will be your internet connection, I think. Especially if you're at home, there's considerations like internet caps. But from a computational standpoint, you're not adding that much. There's a bit more data merkleization, so you're doing more hashing, and maybe you're verifying, a little bit more BLS signatures because now you have these shard blocks that you need to verify the signature. But I'd be shocked if the Raspberry Pi can't support the additional computation. And the Raspberry Pis can support lots of data. That's not a problem. The real bottleneck is going to be your home internet connection.
Well, on that, I'm not going to push back on anyone, but I will maybe just contextualize it a little bit from just like our perspective and the way that we think about it. I think a lot of the way in which we think about the transitions through phase one and also forward is going to be around like resourcing. It's going to be around what do we consider to be like safe, and how can we kind of guarantee SLAs and really high performance and lack of downtime. And the last thing is going to be around all the tooling that we and other infrastructure providers are building. So as an example, for we have something called Global Blockchain Sync, which essentially allows us to take snapshots of the different chains that we support and be able to use them when spinning up new validators or new nodes. So like Ethereum GEP nodes, for example, can be spun up very quickly, and same for archival nodes. And so when we look at ETH2, we made certain decisions around how many validators do we think is an appropriate number to have on a particular client, right? And part of that is going to be how many can the client handle, but another part of it is like, what are they doing? What are, how much money is it going to end up being? And like, what is the risk tolerance that we're willing to trade off there? And as these requirements change, like all of our assumptions have to change as well, because, we don't want to over optimize for liveness and risk getting slashed or have other kinds of like issues come up. And so infrastructure providers like all over that are running, more than just a couple of validators, right? Like if you're just running a couple and you're doing it as an enthusiast and you're doing it on either a home machine or something else, it's not going to change dramatically. But as you kind of start like scaling up and like even small differences start compounding across greater numbers of validators or greater numbers of customers or nodes or whatever it is, then like your calculus has to be constantly changing and evolving with the network to be able to stay, extremely like operationally sound and performant.
Awesome. That's very, very thorough. So just to keep this moving, I'm gonna have one more question before we get into some of the audience questions. So how does Ethereum's sharding approach kind of differ from some of the other sharding techniques that you've seen out there on some other chains? Is that something, I'll go to Hsiao-Wei and Justin first. Was that something kind of built from the ground up, or did you try and learn from some of the other teams that may have started experimenting with that as well? Hsiao-Wei, if you want to go ahead.
Good question. So I think we definitely learned about to have the beacon chain as the one core coordinator to the other shard chains. But speaking of difference, the most different is also that I think no one else is doing some kind of the ETH1 deposit contract and move to the ETH2 world. So that has some actually has some downside here, to be honest, that we have to consider the docking in the future. So in our sharding design, we also consider how to, for long term, we have to consider how to migrate the future state engine smoothly in the later phases. So I think that's my side in our design.
Got it.
Interesting.
Yeah, I mean, so in our sharding, I think we've used ideas from that look very similar to what other folks have done. So specifically, I have Definity on my list. So Definity uses these committees, and that was an inspiration for me, at least, when I read the Definity paper. And we are using committees as part of sharding, but we're not only using committees. We have various kind of optional security upgrades to committees. So the problem with committees is that they could potentially get corrupted, and so we have 3 optional layers of security. We have number 1, what we call secret leader election, which is basically a way to not know who's going to be part of a committee, so you can't corrupt them ahead of time. We have VDFs, which basically improve the randomness and make it more difficult to manipulate the randomness and hence corrupt the committee. And then we also have, we have 4 security upgrades. The third one is what we call proof of custody, which basically makes sure that the committee members are not lazy, like falling asleep, and they actually do their work. And then we have the 4th one, which is a really cool one, which is data availability sampling, which is that in the worst case, let's say that the committees completely fail and are corrupted, we still have this layer of security, this kind of backup, which is slightly higher latency, but a pretty awesome solution with better security assumptions. So I believe that the 2 of them are unique to Ethereum. So the secret leader election aspect. The proof of custody is also unique, and the VDF is unique. So actually, we're pushing forward a lot of innovation there. But there is Lazy Ledger, which is using the data availability sampling, and we're doing something very similar to them there. One solution which I have on my list here, which we've done something different, is Polkadot. So Polkadot have this idea of non-homogeneous sharding. So basically, every shard kind of has its own kind of decentralized application. You can kind of think of it as a small contract with its own shard. We've taken the approach to have everything as homogeneous as possible, and part of the idea here is reducing the friction of cross-shard communication, which I mentioned previously.
Yep. Awesome. I definitely want to extend real quick so we can have some more time for some other questions. Viktor, I know you've worked with a lot of different protocols as well. How do you see it kind of looking like ETH 2.0 versus some of the other approaches?
Well, I love all my children equally. No, but I will say, in terms of there's a couple things. I think there's 2 primary things that I would call out that's very special to ETH2, and that's a little bit different. I think the first part is that the design, I think, really is exemplary. It's really just extremely intentional about what it's doing in terms of enabling decentralization, and enabling a design that is very resistant to state-level interference and other centralizing attempts. To not have on-chain identity, to not have on-chain governance, to have hundreds of thousands and millions of validators eventually. I mean, these are things that frankly took a long time. They were in development basically like from the first day that Ethereum became a thing and people started thinking about it. And it took 6 years to get here. It was a very long road, but it, I think, was all worth it for the design that we ultimately got. And I'm really excited to see what comes out of it. And I think that's very different from other proof of stake networks that I've seen. The second thing I think is the strength of the community. Like, this would not have been possible anywhere even close to it, without the contributors on the research side, on development side, on the client side, on the funding side, on the hundreds of guides people have written, on all the questions people have answered, on all the calls people have hosted. I think that is something that like really sets Ethereum apart. They've been very, that we've been very fortunate to be able to build. Lots of other protocols are working on that as well. But I think that like in terms of how a launch goes, like that helped make this, I mean, nearly flawless. Like there was like the launch, I think, spoke for all the work that people put into it.
Awesome. Thank you. I have we have 1 minute left, so quick round. This one's going to Preston. For those who do not have the infrastructure or technical know-how on how to run a node, can you suggest what could be like a pool to become a validator or to get involved?
Yeah, there are a number of staking pools out there, some with different strategies and trade-offs. I can't recommend one in particular because everyone's needs are a little bit different. But I'd say just do your due diligence. Staking pools are a great way to get involved if you don't have the full 32 ETH or you don't have the capacity or know how to maintain the infrastructure. But do you have to look into it for yourself?
And would you prefer something like a decentralized protocol, such as like Rocket Pool? I know is one. There are a couple others out there. What are some thoughts on that?
Yep. Yeah, I definitely prefer the decentralization route if you can. Like I said, everyone's needs are a little bit different. So, yep.
Awesome. We are out of time. So before we get kicked off, I just want to thank everyone else for joining us today. That was it was a lot of fun to hear directly from the source, everything that was going on, and looking forward to keeping up going on. So yeah.
Awesome. Thanks so much.
Thank you guys, and congrats.
Thank you.